Comparing and evaluating multiple projects whose useful lives are not exact same. In this case, we are comparing these three projects. The useful life for A is 6 years, B 12 years, and then C 4 years. We have shown in the earlier video how to compare these, assuming these projects will repeat until to a common study period, which is 12 years. You can check that video. So the idea of repeatability is basically every 4 years you reinvest that project C until you go up to a common study period, which is 12 years. In this video, we'll be talking about the co-termination assumption. So we'll assume that the project A will end at 6 years, project C will end at 4th year. However, then we'll see that even though project C ends at year 4, it will continue. We'll assume that the money will be kind of reinvested at the same rate, 20%, and it will continue up to 12 years. Same thing for A. We'll think of, okay, it will cut at 6 years. However, it's going to produce at the same rate up to 12 years, up to a common study period. So you're doing still the same common study period. However, the thinking process is going to terminate at 6 year. C is going to terminate at 4th year. So in this case, we'll have to use the future value calculation. The first, we're going to calculate the future value for the useful life of the project, and then we'll convert that up to 12 years. So we can simply type that function called fv, and then the rate is this 20%, and then the number of period, compounding period, and then the payment. Now remember, we'll have to use it. We got two cash flow for this payment, the revenue and expense. And remember, in Excel, we have to use a negative sign before to kind of get the desired sign. In this case, we're going to add both of them. However, we need an opposite sign to get our desired sign. You can directly use $30,000, which is 35 minus 30. 35 minus 5, which is $30,000. We can use negative $30,000 here. It will give you the same answer. And then we have this present value, which is this guy. And then end of the period interest compounding convention, plus we're going to get that $20,000 back at the end of the useful life. So this is what you're going to get from this project A, and then project B and project C, and so on. Now what you have to do is we have to take these future values to that common study period. So I'm gonna just type this as a study period, which is 12 years. So what are you gonna do? So this money, $19,299.20, we're going to get that in year 6, and we are converting that to year 12. So we assume that that amount of money is gonna be generated, assuming by this project at that 20% mark, the minimum attractive rate of return. So simply we can use that FB function again and convert these at the same rate. And then for the number of compounding time, so this money is at year 6, we are taking it to year 12. So it's basically compounding for 6 years. However, I would like to do this, if that makes sense, so that in here, so everything gets kind of automatically calculated. And then payment, there is no payment. We are only converting this future value, which is present in this case, to the 12 years. Now again, use the negative sign so that we get our desired sign. End of the period interest compounding convention, which is 0. And then just copy all the way here. So these are the cash flow generated for 12 years study period by each of these projects. So again, B looks like the most attractive project in this case. So this is how this co-termination assumption work. You'll have to use the future value method to perform the calculation and make decision based on that.